All right, this is Mr. Weyrich. Going to go over this review with you just real quick. Start off, we're doing mostly probability on this. What's the probability if you choose two shapes at random that you pick a triangle, toss it to the side, and choose another triangle? So we count the shapes. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 shapes. And 1, 2, 3, 4 of them are triangles. So on that first one, it's 4 out of 16 for the number of triangles. But then we're throwing that triangle to the side. We only have 15 shapes left, and now only 3 of the remaining ones are triangles. We multiply this out, and then however they want us to express the answer, fraction, decimal, that's what we're gonna do. Pizza Shop has available toppings of bacon, peppers, anchovies, onions, olives, and pepperonis. How many different ways can a pizza be made with 4 toppings? This goes back to the permutations versus combinations. Does order matter? Does the order matter? And on pizza toppings, the order really doesn't matter. We have 1, 2, 3, 4, 5, 6. So this is from 6, we are choosing 4. So it would look like this. If you're doing this on Desmos, it would be N, capital C, lowercase r, and then the parentheses from 6. We choose 4, something like that. If you type that one in, that should get you your answer, all the different ways that you can do that. A survey was conducted at a local college to determine if students lived in the dorm, played intramural sports, or neither. Survey found the probability the student lived in the dorm was 0.40. The probability the student played intramural sports was 0.76. Probability that a student lived in the dorm and played intramural sports was 0.24. What is the probability of D given S? The probability that a student lived in the dorm given that they play intramural sports. So this is going to be... given that they play intramural sports means we're limiting the bottom of the fraction to a 0.76. And then the ones that are going to live in the dorm for that, that's these living in the dorm, so 0.40. So this is the 0.40 out of 0.76 is what we're going to be dealing with. You can break this down into a table to look at it a little more clearly. But it's basically, here's the dorm, yes or no. And the yes or no totals are 40% and 60%, okay? And then the played intramural sports, the totals are gonna be 0.76 for the yes, and then that'd be 0.24 for the no, and then we have the dorm and sports as 0.24. Oh, actually, that should be given that they play intramural. Okay, this 0.40 is not right. This should be the 0.24. The probability that they're doing both out of everybody that's playing sports. So yeah, 0.24 out of 0.76 is what we should have there. Okay, let's look at the next page. Suppose you randomly select juniors and seniors and ask about whether or not they're attending a school concert. What's the probability the surveyed student is a junior or is not attending the concert? So the juniors would be these. Not attending the concert would be these. So this is 42 plus 64 plus 37 out of everybody, the 220. Okay, just got to be careful with the wording. That or is means we're going to have a bigger group, and you don't want to just jump on these totals because then we'd be counting this 64 twice, and we don't want to do that. Barrett competes in the Bassmaster Elite Series. He hooks a fish 40% of the time. What's the probability that Barrett will hook a fish and hook another one right after? That would be 0.40 times 0.40. Okay, so it should be 16% that he's going to hook 2 on consecutive ones. Write an example of an independent event. So this would be like you can flip a coin and then you can roll a die because the coin flip does not affect the roll of the die. We would calculate those. It would also be basically if you put things back. If you draw a marble, you put it back, and then you draw a marble. Those would be independent, okay? The fact that you drew a blue marble first doesn't mean anything if you put it back and you give yourself an equal chance. The dependent ones would be like that very first one with the shapes. You're throwing it to the side, so it affects what you have left. Mr. Mattis has a bike lock. It has a 3-digit code. The digits need to be chosen are from the integers between 0 and 18. They cannot be repeated. So for the first one, there's 19 because 0 does count as a number. For the second one, there's 18 because we cannot repeat that number. And then for the last one, there's 17. So you would just multiply these all together. That's the different ways you can come up with everything here. Spinner shown is divided into 8 equal sections. You spin the spinner 2 times. Cool. Everything's going to basically be 1 out of 8. What's the probability the spinner lands on green the first time? There's 1, 2, 3 greens, so that's 3 out of 8. And then red the second time, that's 1, 2, that's 2 out of 8, and we would multiply those together. The spinner lands on blue the first time, that's 1, 2 blues, 2 out of 8. And then yellow the second time, that's 1 out of 8. So when you multiply those together, those would give you your answers. Some of these you can reduce, use Desmos, reduce it if you can. And then the back page here. The game board below has 12 sections of equal size. The middle section is 4 times as large as each of the other sections. If a game piece randomly lands somewhere on the board, what is the probability it will land in a portion of the board that is black? So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the 12 of equal size in the middle section, 4 times as large. You could honestly just break this down by the rows and columns and just say that this is 16 spaces. So out of 16, we've got 1, 2, 3, 4, 5, 6, 7, 8. That's 8 out of 16, or I know that one pretty easy offhand. That one's 50%, or 1 out of every 2, or 0.5, or however they want you to express that. Make sure you try to finish this review up, and you should be able to use it on the test. We'll take the test tomorrow.